Hi, my name is Ken Westin. I'm Director of Security Strategy at Cybereason. Today I'm going to be presenting Containing Chaos in Cloud Containers, and I'm going to go into a little bit of content around cloud security in general, and then we're going to discuss some of the challenges with containers and container orchestration, particularly when we're dealing with modern applications that many organizations are dealing with today. First off, we have a lot of challenges when it comes to cloud security, particularly when we saw the pandemic as organizations in many cases were forced to migrate to the cloud. I think a lot of organizations were planning on slowly moving to the cloud, particularly when it was cost efficient. But with the pandemic, with work from home, there was a really big shift to the cloud. And a lot of times, many organizations weren't necessarily prepared for this massive shift. They started leveraging a lot of different cloud services, different cloud architectures. Many times they have different cloud applications that may be in different cloud platforms, whether it's AWS or Google, GCP, or even Azure. I've worked with many organizations that actually had applications in all three and even other ones on top of that. So there's a lot of challenges with that. And also when you're dealing with security, when it comes to cloud, it's a completely different concept in many respects. A lot of the technical skills that you have for managing infrastructure and things like that in a traditional security environment kind of goes out the window when you start migrating things to the cloud, particularly when you're dealing with massive applications that you're scaling at a petabyte scale. We've seen a number of breaches that have been a result of cloud security lapses, whether it's a vulnerability within an application that gets exploited. You may be familiar with the Log4j vulnerability. Well, this had a significant impact on many web applications, and many cloud security practitioners were left scrambling when this occurred. We deal with some of the traditional types of attacks against maybe a network, particularly when we're dealing with a virtual network on a cloud environment. There are man-in-the-middle attacks. We also see an increase in crypto mining attacks, where the idea here is to stealthily compromise a cloud workload to be able to leverage it for crypto mining purposes. Also, we even see ransomware as well in the cloud. And another common issue is key compromise, particularly when you're dealing with container escapes, like with we have Kubernetes that's handling the orchestration. You may have Docker that's your container. And if there's a vulnerability and an attacker is able to maybe leverage that vulnerability or misconfiguration, they can actually break outside that container and then access the host machine, where they can then compromise key and they can move laterally from there as well, leading to an even larger compromise. So the challenge in the cloud, there's a lot of issues that we're dealing with in the cloud that we may not necessarily be dealing with in a traditional security architecture, like a traditional network. A lot of times the cloud security is incredibly siloed, and a lot of times it's very almost bespoke, because it's so different for each of the different cloud platforms. They have different languages, they have different techniques that they're using to secure it. Pretty much all of the cloud providers have this sort of shared responsibility model, where sure they'll handle the hardware and things like that, but when it comes to a lot of the application security and a lot of the configurations, that's still going to fall on the practitioner. And again, a lot of times organizations may not have a lot of the cloud skills within their organization to be able to manage these massive applications. They're increasingly distributed, and I used to work at Splunk and as well as Elastic, where we were dealing a lot with very large data sets across all these different cloud environments. And it was really a great opportunity for us to be able to scale, but there is an increase in complexity when it comes to that, particularly when you're dealing with multiple cloud infrastructures that many organizations are dealing with today. You may have limited visibility. I see this time and time again. A lot of times organizations may be bringing data into their Splunk or their Elastic cluster from their firewalls, from their traditional security tools, but a lot of times they're not bringing in the data from their cloud infrastructure. And a lot of that is primarily due to cost. There's a high volume, high velocity amount of data that's actually flowing through those systems. And then, of course, there's also technical constraints as to why they won't do it. If you bring that data in, you also need to be able to write detection rules. You need to be able to hunt through that data and actually be able to identify it. And a lot of times I'm finding security practitioners may not quite understand all of the data that's coming in. They may not know what's actually relevant and what's important and what to highlight. And we'll cover some of those today in this presentation towards the end. We're leaning a lot more towards a lot of automation. Again, we have a lot of forensic data. When there is an incident, there's just tremendous volumes of data that we need to be able to sift through, and we need to be able to do it quickly. And a lot of organizations may not have the data platforms to be able to do that. Oftentimes, some of the alerts you get may be lacking business context. I've been on site with customers where they have malware that's been identified on a particular system. They get an IP address, but they have no idea where that particular system actually resides because they don't have that additional context around the asset inventory. They don't know what that is. And this is actually makes it even harder when you're in the cloud, because a lot of times those machines are virtual. They're ephemeral. They go up and down. So the system that triggered that alert may not be the one that's actually up currently. So there's a lot of challenges there. And we're also seeing multiple stakeholders and a lot of different business objectives when you start moving things to the cloud. You're talking with a lot of different groups. I think particularly when you start having DevOps and trying to communicate with security, there's a lot of different challenges when it comes to that, because they have different focuses in areas, and we'll talk a little about those personas. The DevOps, they're more focused on uptime and efficiencies and speed, whereas the security folks are more focused on risk and things like that, not necessarily speed and uptime. So when we're dealing with a cloud versus security, we're dealing with very different personas, and oftentimes, many times different personalities. I always like to say that security folks are from Mars, DevOps people are from Venus. First off is you have your site reliability engineer, and their focus is more around the DevOps space, where they're really focused on speed, they're focused on uptime, as well as business continuity, right? They want to keep the applications up and running. Oftentimes there are applications that are generating tremendous profit. If those systems go down for whatever reason, whether it's an issue with the software or if it's a security issue, they're going to want to keep those systems up no matter what. You have your DevOps engineers, and they're focused again more on the development of these applications. They have a really great knowledge of a lot of the DevOps processes and systems, but they may not necessarily have a security mentality. We're starting to see more focus on this in a lot of the like AppSec and application security, like the OWASP groups and things like that, where they are focusing a lot more on security on the application side. But oftentimes, that's still not going to be their primary focus. On the DevOps and SRE side, they often have deadlines, they have SLAs they have to meet. And so when the security guy comes along and tells them that, hey, we have a vulnerability in an image we need to go through and fix, we need to slow down our development process, this can be a bit of a challenge. But on this flip side as well, a lot of times the security operators, the people that are trained in security, they may not understand all of the DevOps processes. A lot of this is fairly new, particularly if they came from a more traditional security background. So again, they're speaking a lot of the different languages, and they have to learn how to communicate. And so I'm actually seeing that, particularly when you're dealing with sort of this hybrid environment where it's cloud as well as traditional on-prem, the more that these groups can actually communicate and work together, the better off everyone's going to be. So some of the common approaches when it comes to cloud security, you might hear a lot of acronyms in security. And so when we go to the cloud, of course, we had to invent whole new acronyms. We have cloud workload protection, and I'm going to touch a little bit on that today, just because that's where I have a bit more experience, particularly when you're dealing with detecting malware and malicious actors and things like that. You have cloud security posture management, which gets a little bit more into vulnerability management. You'll also touch a little bit on the compliance side. A cloud native application protection platform. Again, this is where you have sort of the combination of CWPP and CSPM. You might hear a term referred to as infrastructure as code, but it's just a kind of one of those fancy DevOps terms. And then also the cloud access security broker. This is usually, it's an on-premise or cloud-based security policy that kind of helps enforce a lot of the security policies, not just necessarily going to be compliance, but helping particularly with the configuration management and things like that. I'm going to be focusing mostly today on the CWPP and the CSPM side. So when it comes to vulnerabilities, particularly in the cloud, it can be pretty disastrous. Kubernetes, for example, has had vulnerabilities. It's a great tool. It's amazing orchestrating containers. It's also incredibly complex. Not only does it have a lot of potential vulnerabilities, but it's also really difficult to configure. There's a lot of room for error when you're configuring it, and a lot of times it's incredibly complex. And there's a lot of different attack vectors that an attacker can take. They'll look for misconfigurations. They'll look for vulnerabilities within those platforms. They'll also look for vulnerabilities within your stack. So, for example, if you have an image that gets reproduced where you have a vulnerable version of Apache or a database, for example, then that image is compromised. And you may have a situation where a vulnerability will actually not just have one database, but you'll have hundreds of instances of that vulnerable database that are actually part of your application. So again, that raises a lot of additional challenges when we're moving into the cloud from your traditional approach to applications that might be a little bit more monolithic. So when it comes to doing any sort of attacks, they're referred to as a container escape. It sort of looks a little bit like this. This is sort of the simplistic model. But you may have a lot of security pods that are being orchestrated through your Kubernetes that also have all of your containers. But all it takes is one misconfigured pod or one misconfiguration in an application that an attacker can then get a foothold into that environment. Once they're able to do that and they can escape that particular container and then they can get into the host file system, that's where we'll actually see a lot of applications get compromised. Because once I'm inside that host file system, I can then access any of those containers if I wish to. I also can get access to keys, which will then also allow me to move even further within the environment, conducting additional lateral movement, possibly compromising additional hosts as well. So this is a very common attack. There's a really great video I recommend, Ian Coldwater, and they did a video around how to do these, and it was quite simple. Again, they looked for a simple misconfiguration, and they actually had one-line exploits where they were able to escape some of these containers. So again, oftentimes it's going to be a misconfiguration, but you also will be dealing with vulnerabilities occasionally. So I borrowed this image from Hacking Kubernetes. It's a really great book. It really allowed me to sort of visualize all of the different places that an attacker can target an organization or target a cloud application. So they can look at the cloud infrastructure itself. They can target the application code, particularly if it's maybe bespoke code that your organization is writing. Maybe you're on Uber or something like that. That's where they can start their attack. They can also target the developers. They can target your traditional endpoints as well. You may have seen the recent attacks that we saw with Lapsus, as well as what's happened at Uber and Rockstar, where identity was compromised through a sort of a phishing tag and an MFA fatigue attack. But once the attacker got in and they were able to compromise that identity, they were able to pivot in access code. And inside of that code, they were able to actually see that there were hard-coded credentials for some of their critical services. So they were able to then move laterally within the organization and further compromise all of those different systems. Now, what's scary about that is that it didn't necessarily require a highly technical adversary to get into that organization. We're not dealing with nation-state actors that are taking advantage of a zero-day vulnerability. What we saw was a younger kid that is familiar with these techniques, social engineered his way into the environment. And then he was able to exfiltrate data, took screenshots, and caused a lot of damage. Luckily, at that situation, they could have caused some pretty serious devastation if they wanted to do like a ransomware attack, or if they wanted to wipe all of their applications and things like that. They could have caused a lot more damage than what has actually occurred. But it does raise a red flag and a warning just how easy some of those types of attacks are. But when we're dealing with cloud attacks, right, that can be one attack vector, but they can also, again, they can target the application, they can get into the DevOps process as well. We've seen situations where malicious code has been deployed. If you remember SolarWinds, that's a really great example where it's sort of a supply chain attack where the attackers were able to inject some of their own code, and then it was actually pushed out to a lot of their customers. And that was a devastating attack in many cases. It hurt SolarWinds' reputation. There was also a potential intelligence compromise in some cases with some of those applications that were breached as well. So again, it's incredibly complex when we're dealing with Kubernetes and these orchestration layers. On top of that, we have Docker, and then we also have all of our other applications that are within those containers that we're used to dealing with that are also vulnerable. Just examples of some of the tools that can be abused with some of the attacks that we've done. A lot of times they're not going to be leveraging any sort of exploit tools or anything like that. They're not going to try to load any of their own binaries. What they'll actually look for is try to leverage some of the sort of the lull bins or the living off the land techniques. So looking for tools that are already within some of these containers and some of these applications. And a lot of times maybe you have the wrong version of a shell that provides the attacker with a wget command, where they can then download a malicious package or a file to that system. And then maybe leveraging cat to look at the containers of some of those files as well. And then the kube control, which is a common tool that's used for managing Kubernetes. This is the example I was talking about from Ian Coldwater in their presentation at Black Hat, where they had a one-liner where they were able to escape containers simply by entering a few commands, right? So again, it's a little more difficult than you might see like with a traditional malware attack, where maybe they deploy ransomware, or you might see them leveraging Metasploit or some of these other tools. Oftentimes when you're dealing with cloud security, they're going to be trying to leverage the tools that are already within the environment. This helps them evade detection, and it's also easier for them to compromise the host. So when it comes to cloud workload protection, what things you want to look for, there are a number of vendors. I work at Cybereason, so of course I have my own opinion about which product has the best offering, but there are a number of them. All of the EDR vendors have some sort of a CWP offering now. Again, they've moved beyond the traditional endpoints, and now they're incorporating some of these other methods, right, for cloud architecture. The first thing you want to be able to do is do discovery. You know, what workloads are actually running on this particular system. We want to have it be easier to manage, so straightforward for managing all of the workloads that you're going to be seeing. One thing you want to be able to do too is be able to look not just in the containers themselves, but also on the hosts. And then what we refer to as sort of cross-container correlation, where you can actually see what's happening across these different container environments. And then we can see that, hey, this system, we see that this has been potentially compromised, and we're seeing similar behavior on two other containers, right? That's where we can identify we may have a larger image issue, where it's not just necessarily those individual containers, but the image from which they're being spawned from. We also want to be able to do vulnerability assessments on all those workloads, right? As I mentioned, if we have one vulnerability, it doesn't just exist in one instance. It can have hundreds or thousands of instances across our entire cloud infrastructure. So we need to make sure we have the ability to not only identify those vulnerabilities, but also rapidly remediate and patch them. We need to be able to enforce policies. So when it comes to the configurations of Kubernetes, for example, if there's a drift within those configuration files, we need to be able to identify that, and maybe even have to retroactively go back to it if there is an issue. If you push out a security update and it caused the application to crash, your SRE engineer is going to be very upset, and so you're going to have to roll that back as well. And the faster you can do that, the better. And also integration is going to be important. So the ability to incorporate that into your DevOps processes is going to be critically important. If you have a tool that doesn't play nice with maybe one particular cloud provider, that can be a bit of a challenge. Visibility and detection. So when you identify something malicious, having an agent that can identify that is going to be really helpful. Because oftentimes they can actually take automated actions to mitigate some of the threat. And the faster you can identify and remediate that threat, the less likely you're going to suffer from any sort of downtime. You're also going to be able to stop that attacker in their tracks. So you may be able to stop the attacker before they actually compromise a particular host, or if they compromise your keys, for example, as well. And having that visibility of key compromises can be critically important as well, because you need to know which applications may have been compromised, what keys do you need to be set. So it's critically important to have that visibility.